Figured it's a good time to just get going and talking. I'm Dennis. This is Sebastian. I'm an agile coach and consultant at Curiously Correct, which was my own startup to help people develop agile practices in their teams, particularly with database teams. Let Sebastian tell you a little bit about himself.
I'm a SQL stylist with equality.net, and I help people to write clean, easily readable, well-maintainable, and as much as possible error-free code. And today we are here to talk about test-driven development.
Right. Which we've entitled the session Thwarting Database Defects, and we hope by the end you'll see how those two things are related. So just as a quick poll here, who here has done any kind of automated unit testing before, whether that's in the database or in C# or Java or whatever? Okay, so about 20% or so. And who's done it in a test-driven fashion? Okay, great. And among everybody else, who's even heard of or have an idea of what test-driven development is? I would hope at least the hands that, said they've done test-driven development would go back up too, right? Okay, good. That just gives us some information on where to guide the talk to today. So way back when I'd first started outside of school, I'd come across a pesky little defect in my code that made me start thinking about automation and detecting problems early. You see, we had this system, and in SQL code you have those pesky where clauses, and you always kind of want to get them right. But we had a particular where clause that every time somebody put in order into a sales entry system, it would start overwriting other orders in the system. Well, lo and behold, that meant the wrong equipment got configured and installed, and it's a mess. We didn't want to get there. We want to kind of prevent these kinds of things, regardless of whether, it's a where clause thing or, something in our update statements. Really anywhere in our SQL code, we want to prevent problems from happening. And why do we want to do that? It's because when we have problems in our database, they tend to be expensive. Sometimes monetarily, sometimes, they could be somebody's life if we're working in a healthcare system, but they could at the very least be embarrassing, so we still want to avoid them that way. So what makes them expensive? They can be hard to find. SQL code is bizarrely complex when we look at it. Anybody who's come from a OO or procedural background and starts reading through a SQL statement, starts going, well, this is not, we don't start reading it at the top and read down to the bottom. We actually start reading it somewhere in the middle to figure out what tables we're dealing with. So defects in there, and because they involve so much complexity, tend to be a bit hard to find. Because of the data involved, and because how hard it can be to read and maintain this code as it is, it can be dangerous to fix because we're likely to introduce something else and make it go wrong. We've all probably been in situations where we went and fixed something just to break something else while we were doing it. With data, pesky data, we can permanently corrupt it. In the sales order entry system I'd referred to earlier, there was no way to go back and figure out what the salesperson actually entered in the first place. Backups weren't going to help us. Because by the time the fifth person entered a sales order, all kinds of records were updated that shouldn't have been. And people can make bad decisions on the incorrect data. And this is really the worst part. And this is really reflective of what our data represents. It's extremely valuable to us. If we have the wrong data, or we use it in the wrong way, people are going to do silly things. They're going to install the wrong equipment. They're going to administer the wrong amount of medication. They're going to build the wrong financial forecasts. So we don't want that either.
So the main reason why backups didn't help in Dennis's situation was that because between the strong update happening and the system being installed and the client actually figuring out that there was a problem, often 3 months or more had gone by. So all the backups had been recycled at that time. The backups had still contained the correct record. So what we want to talk about today is how to reduce that feedback cycle length. And agile development in general is all about reducing the feedback cycles that we have in software development, starting from the beginning, the design, going down to test-driven development. Test-driven development is the smallest cycle within the different cycles you have in software development. When you execute it, you start out by writing a failing test, a small test. You try to describe a small feature that you would like to have, that you would like the system to be able to execute. Then you write a little bit of code to implement that feature. A little bit means you write just enough code, a minimal amount, to implement that feature. And then in the third phase, you clean up what you have done. You try to make the code a little better, a little easier to read, a little more maintainable. That whole cycle takes about a minute or two. So it's a very short feedback cycle. Every time you change your code, you run all your tests again. And that means if you broke anything accidentally, one of your tests will fail and will tell you that you broke the code.
So if we talk about why we do this test-driven development thing and what the whole idea is, how many people work in organizations that have testers? Okay. Everybody else go get some testers. They're actually very important, okay? And one of the things I've seen developers get the misconception of when they start with test-driven development is, well, I'm a developer, and now you're asking me to do all the testing. That means one of two things. Either my testers aren't doing a good job, which I find not to be true in most cases. They tend to do excellent jobs. Or you're saying, well, we don't need testers at all anymore. I'm doing all the testing. Okay, that's not the case. The truth is, test-driven development is one development practice of many that helps us find and reduce the amount of defects we end up putting into our software. Okay? What we want to do as developers is we want to prevent our testers from having to find every little nitty-gritty last defect and focused on the interesting ones, the ones that are hard to find, okay? Because they're thinking from a testing model. Their job, their training is all about figuring out the hard to find things, and if they spend all their time finding the easy to find things, we're not utilizing them properly. Second, we want to build ourselves into a system where if we fix something, we don't break that something again. Or if we develop something and we know it works, we don't break it again later. What this requires us to do is to have some form of automated tests that do that. Test-driven development will drive you in that direction. As Sebastian pointed out in the previous diagram, we're starting off our development by writing a test. Not figuring out what code we should write, but start out by writing a test. This flips the whole model around. Now we're focused on quality right from the beginning, okay? It's not, something, well, we'll write it, we'll kind of get to work, and then we'll really test it and fix it back and forth. Instead, we're saying, this is exactly what it is I want to build. So that, in general, improves the quality of it. For those who have ever sat down and kept their own bug diary, probably not that many people actually do it, but if you ever get the opportunity to just sit down, put a notebook next to your desk, and say, okay, well, every time I get a defect that happened to be in my code, jot it down, see what you learned from it over time. people have kind of looked at tracking these things, and as they implement automated unit tests, the number of defects that they produce themselves goes down. So quality is one of the main reasons. Design is another one. If you're going to write a test case for something, and then write the code to make that test case pass, you're going to force yourself to design smaller, easier to use modules with better names, okay? So when we look at what kinds of quality we want in our design, what a good design looks like, a good design is something we can maintain, understand, where we can read it and figure out what it was, the intention was. So test-driven development forces us into that, because in order to write code that makes a test pass, we have to write it small. We have to think about the names of things. The test will force us that way. For that same reason, the code becomes easier to maintain. Better design is far easier to maintain than giant monolithic stored procedures or queries. Furthermore, if I have the safety net, if I've built up the safety net of test cases over time, I can start making changes. I can improve my design through refactoring without fearing that I'm breaking something. Furthermore, I can add new features without fearing that I've broken something that exists. So that's why we're doing it.
So we spend about 80% of our time reading code and only 20% writing code. So getting to a place where your code is easily readable makes your job a lot easier. Talking about making your job a lot easier, you can do all this testing in a manual fashion, but there are a few advantages of trying to automate your tests. If you can execute all your tests with the press of a button, it's easy to do that. You're going to do it a lot more often than when you have to manually go straight through there, execute procedures, compare results. It is repeatable. You can do it anytime you want. You just press that button and your tests run. It most likely will execute a lot faster than the manual execution. Again, it allows you to run your test more often. And finally, you're much less likely to get an error in there than if you have to look at your test, look at the test output, compare numbers manually. So automation makes it easier, makes it faster, and with all that increases the likelihood that you run your tests. The more often you run your tests, the earlier you detect if something went wrong.
So, we don't actually like throwing a whole bunch of PowerPoint slides at people. So we tried to make this presentation about 80% looking at actual code and seeing what test-driven development is actually like. So you guys get a kind of first-hand experience. And hopefully enough that you could take it at home and try it out. So what we'd like is we'd like this a little interactive. So if you happen to have a question or comment or concern, please throw up your hand and ask it during, this discussion. We're happy to stop and answer questions or alleviate things, especially when looking at code, because if we throw up a block of code and it's not quite clear what's going on, then the next block of code isn't going to make any sense either. Okay? So what we're going to do is we're going to show you how to do test-driven development with a tool called T-SQL-T. T-SQL-T is an open source unit testing framework. It's a project that Sebastian and I started writing a number of years ago when we were frustrated with some of the barriers we were running into with currently available open source tools at the time. Now, Redgate went ahead just about half a year ago now, maybe a little bit longer, and said, well, we like this idea. We want to tell the story about testing and continuous integration and deployment and helping database developers be a little bit more agile and fit in with the rest of development. So they took T-SQL-T and built on top of it SQL Test, which fits straight into Management Studio and is pretty awesome to use, we found. So that's kind of a background on where we're going with the next few things. You want to explain what this is doing?
Yep, so this is a test. A test in T-SQL-T lives in a schema. Any object in the database lives in a schema. The schema that our tests live in is marked as a test schema. To get the schema marked as that, you create it by calling T-SQL-T new test class, providing the name of the schema. The reason we call that class is because with the T-SQL-T framework we are following the patterns that were set by the OO community, and they started developing testing frameworks, for example JUnit. Tests that belong together, that cover an area, one area of your code, they live together in a class, a test case class in those frameworks. So we took that term and called that class as well. But as I said, it's just a schema under the covers. To write a test, you just create a start procedure. Any start procedure that lives in a test case schema and starts with the word test is considered to be a test by the framework. If you want to write other procedures, helper procedures, utility procedures, as long as you don't start the name with test, you can do that and the framework will ignore them. So you can put those objects into the same schema, which makes reading the code again easier. A test in general has three parts. Follows the AAA pattern. The three parts are assemble, act, and assert. In the assemble phase, you set up your environment. You can put data into tables or empty out tables, things like that. In this example here, that phase is empty. In the next phase, the act phase, you actually execute the code you're trying to test. So here in this example, we have a select statement that puts the result of the concat name function into the result variable. And it's passing in a few values into that concat name function. At this point, that function doesn't exist. In TDD, you write a test first. In that test, you describe what you would that object you're creating to look like, what you would like it, what you would like it to be usable. So in this case, we want to be able to call this function passing in the three parameters that look like name parts. And we want the output to be a concatenation of those three parts. And that is defined in the assert phase, the third phase of the test. In that phase, you make sure that the code that you were trying to test actually is doing what you intended it to do. So in this case, we're using the assert equals string method that compares two values, two varchar values with each other, and it will cause the test case to fail if they don't match, or to pass if they do match. Again, a convention that we borrowed from the NUnit or JUnit community is any assert statement that has two parameters will take the expected value first and the actual value later. Why that is, we're going to see in a few moments. I have compiled that test a little earlier, so let's see what happens if we run it. And
pull that up on the screen a little bit higher.
A little higher. So what we see here is, as expected, it can't find that function. So the first thing to do is to fix that.
So in test-driven development, when we write the code to make the test pass, we write the simplest thing we can possibly do to make the test pass. Here we're returning a hard-coded result.
Which is totally fine.
It's about as simple as you can get, and feels really silly to do. As we talk through this, you'll kind of see why this is actually important.
So with that new function compiled, we rerun the test, and now it is passing. So it's time for a new test. Now in T-SQL-T, the new test class not only creates that schema, before that it drops that schema if it exists. And before it drops the schema, it cleans out all objects that might exist in that schema. So after you executed the new test class, you're at a clean slate and you can create test cases without having to worry about pre-existing test cases. In that same file, you can then put all the test cases that belong into that class. So we have the same test case that we had before up top, and right under there, the new test case. The new test case now passes in an empty middle initial, and we expect the output to not only not contain a middle initial, but also to not contain the dot that was there in the first test case. When you name your test cases, you want to be as expressive as possible. So SQL Server allows you with a bracket notation to put almost any character into the test case name.
Who feels queasy about naming their stored procedure with any character in the name of it? No. Okay, at least 5 or so. Okay, that's good. That's normal. As you know, people who write code or DBAs trying to maintain standards of how they're naming things in their database. Yeah, we normally wouldn't do that. We feel like it's okay though, because this is a test case. It's not living in production. By the way, don't put your test cases in production. That's a big no-no. And we'll see why a little bit later, why that can get you in trouble. But at the same time, we need to read this thing. And we need to read it far more than we have to type it. In fact, once we've typed it the first time, we don't have to type it again. The framework kind of takes care of that for us. Okay? So if we can make this thing as expressive as possible when we see a list of test cases, and when you start getting really into this, you start getting, 300 or 400 test cases, and looking at a list and seeing the 3 or 4 that fail, being able to actually read those test case names, huge time saver. Because otherwise, you have to go back into each one of those test cases and start figuring out, okay, exactly what was it you were trying to do. So a well-named test case, one that you can read very quickly, is great. If it makes you feel so queasy, you don't have to do it, but I would certainly encourage you to experiment with the idea and see where you get to with it.
And you do not have to ever write this again. You write it once, you name your procedure, the rest is handled by the framework. So don't worry about having to type that name again. You don't have to. So let me compile that test case and run it again. So the SQL test framework sits on top of the T-SQL-T. The SQL test UI plugin, SSMS plugin, sits on top of the T-SQL-T framework. So let me show you how to run the test cases if you don't have SQL test. You just type in tsqlt.run all and execute that, and it produces an output like that. It lists the test cases that were executed, and after each test case it puts the result of that test case. In this example we have one successful test and one failing test. More information about the failure you can find at the top of the output. There it says the test that the empty middle initial does not get punctuation failed. We expected John Smith, but we got John M. Smith, which was kind of expected again because we still have that hard-coded value in there.
So as a reminder here, if we look at this, over here on expected and actual, it's figuring that out by the order of parameters that we pass to that assert equals string. And that's why it's important that you put expected first and actual second. Otherwise, this output makes no bloody sense whatsoever. I can't tell you the number of times I've looked at the results of a test case and gone, man, that result makes no sense whatsoever based on the code I just wrote. And then read through the test case and go, oh, it's backwards again.
So pay attention to that. One other thing that the framework does is it throws an error if any of the tests did not execute successfully. So looking at that icon down here, you can see if any test case failed. If it is a green, whatever it is, circle, then everything went well. If something did not go that well, you have that triangle here. But we are in a red gate event, so let's use SQL test to run this test. And need to refresh the test list before executing them. So again, the test is failing. Down here we have the same failure.
And can you throw that window back up real quick again? The SQL test. So one of the nice things that we like about SQL test is actually reading through the text of here and seeing the failure and success is okay, and we can get that pretty quick. But here it's just we look for the red and we look for the green, and it's very quick to spot, which helps a lot. Anybody who's done any kind of automated unit testing in another language that has a plugin with it will know it's much more fun to use the plugin than it is to jump out to the command line and read the text.
Okay, let's fix that test. So now we just put a small case statement into the middle of the function. We leave the hard-coded first and last names in there. The reason we do that is there is no test asking us to do anything different yet, and we just want to do the minimal amount of work to get this test case passing without breaking the first one. So this case statement here will do. Compile and run the tests, and they pass. The next test now, we actually go in, and again the tests are all beneath each other. So the new test is down here. The test tests at a different name works too. So this test now forces us to actually implement the rest of the logic. And again, first we run that test to see it fail. That's one of the important steps in TDD is that after you have written your test, you execute it. Even though you know it will fail, if you actually see it fail, you have the confirmation that your test is doing what it is supposed to be doing. And when you look at the output, you see that it is failing for the correct reason and not because of some typo that you made in that test. So that's an important step in TDD, to check your tests before you start implementing code to make them pass. And again, the change is a fairly simple one. We just replace the hard-coded first and last name with the passed-in parameters. Let's compile that and run the tests again. Oops. Something went wrong.
So when Sebastian and I actually go through and we sit together and do test-driven development, we play a little game. It's called ping pong. Has anybody ever heard of the ping pong game in doing pair programming? No? Okay. Oh, at least one person has. Great. Do you want to explain what it is?
One person writes the test and then the next person writes the code for.
Right, exactly.
Keep going. One person writes the test.
Yes. So it's one of those pair programming techniques that guarantees both people are still awake. I was having a great discussion yesterday after the event, and he was telling me about how much he hated pair programming because he felt intimidated because he would spend, an hour sitting on the keyboard typing the code, and the other guy was sitting behind him watching, and he felt intimidated watching. And I'm like, you don't have to feel, if you're doing pair programming that way, you don't have to feel intimidated watching. The other guy's behind you sleeping. So ping-ponging is a great way to make sure, A, both people are awake and you're actually getting value out of the pair programming. In this particular example, when Sebastian and I were preparing these things, it was my turn to write the code. And clearly, I did not write it correctly. And, okay, this is silly. We're concatenating names. We probably wouldn't even do this in the database. We'd probably do it somewhere in the presentation layer. We do this here in front of you because it's a simple enough idea to grasp while we're throwing all this other unit testing stuff at you. But that's a pretty easy typo to make, okay? If we look at the results, can we pull them up a little higher? Or
Not really.
close to you.
Doesn't help.
Oh, okay. You can see we're just missing a little space here. We smushed Frank and his middle initial together, and we smushed John Smith together because we didn't stick a space in there. Pretty easy thing to do, okay? Like I said, we're probably not concatenating names in the database so much, but I could have just as easily typed a 1 instead of a 2 when I was adding, incrementing a loop or, adding some financial records together. So these kinds of mistakes are actually pretty darn common. By having automated tests that we built up over time, we prevent ourselves from making these kinds of mistakes in the future. At this point, as we've talked through things, are there any questions about what's going on here? Okay. So let's move on.
Let's move on.
Did we get the test passing?
Yes.
So
I
another
silently put that missing space in there and reran the tests, and now they're all passing again.
So another trick in test-driven development is you can't really move on if you have failing tests, because then when you start adding new tests and new code, you won't know if it's failing because of the new stuff you just did or the old stuff that was causing it to fail. So failing tests that live too long start telling you nothing, and most people start deleting them or disabling them, and that just tells you the whole process is breaking down. So if you get into a spot where it's like, I have a lot of failing tests, and I've had a lot of failing tests for 3 months, something isn't working.
So, we're in a database. We work with tables and result sets and things like that. So we need a way to compare those with each other. And a third equals table provides that. A third equals table takes in 2 table names and then looks through the data in those tables and fails the test if there is a mismatch somewhere in that data. In this test, we actually have a piece in the assemble phase. The piece just makes sure that the orders table is empty. Now, if you work with code that can encounter many objects, a set of objects, you want to test. You want to write a few tests to make that work, and test case heuristics can help you with figuring out which tests to write. You don't want to write a test for 1, 1 for 2, 1 for 3, and then go on forever, because you would be going on forever. Instead, you can use these test case heuristics that help you how to find a minimal number of test cases, still providing the coverage you're looking for. And there's one test case heuristic that is called 0-1 sum. That says you should test the case that you have 0 records in this case. Then you should test the case that you have 1 record, and then you should test the case that you have a few records. So the first test case to write, you should always pick the most simple one. And starting out with an empty table is probably the most simple test you can start out with. That's why I'm just deleting the contents of the orders table here. Now the test is looking at...
Again, don't run your test cases in production.
The test case is looking at an object order by month report. And the test case says that we expect no rows to get back. It creates down here an expected temp table that contains 0 rows, that contains all the columns out of the actual table. So it creates an empty copy of the actual table, and then it compares the two. So that will only be successful, that comparison, if both tables are empty. Now the actual table is created up here by just putting everything that comes from the order by month report object and putting it into the actual table. This means, this test case, as you can read it here, tells you that what comes back by the order by month report is somehow influenced by the order table, by the orders table. So it's most likely a view. It does not tell you anything about which columns that view might contain, and that is fine. This test only tests that that view does not contain any rows when the orders table is empty. So executing all my tests, this test will fail because the order by month report is an invalid object name. To fix that, again, we do the minimal amount of work and just create a view with that name. Again, there was no mentioning of column names in that test, so we just put any one column in there and make sure that that view doesn't return any rows. That will make that test pass. In the next test now, we look to change that by actually requesting a few columns. So now we are in the 0-1 sum heuristic, we are in the 1 case. So we are inserting 1 row into the orders table with a few values, and then we select 3 columns from the view. Those 3 columns are the 3 columns we are interested in. The view might still contain more columns, that is fine. This test is concerned about those 3 columns, so we mention only those 3 columns in this test. Again, we put whatever comes from the order by month report into the actual table. We have the same create an empty copy line in here, but then we insert a new row into the expected table specifying the values that we expect. So this tells us now if we have the values up top in the orders table, we expect the values at the bottom to come back from the order by month report.
Oh, wonderful red text. So we've gotten this far, but SQL Server can't compile our test case. And it can't. Okay, so in the previous test case, it compiled the test case and the test case failed because the view didn't exist. But here, it can't even compile the test case because now that we have a view, it actually has to make sure that the columns exist in that view. So a test case that can't compile, as long as a test case is written with good syntax, is a pointer to us, okay, we at least have a failure, we can go change the code. Okay, so there's really two instances where if you're following test-driven development, you're allowed to write new code. And that's if you have a test case that doesn't compile and you have a test case that doesn't pass. What that really means is we're not allowed to write code any other time unless all our test cases are passing and we're just doing a refactoring to improve the design.
So the quickest way to get that test to compile is just to make sure that those columns come back. We are not worried about the values yet. So we just put some random values in there and run the test again. No, and compile the test again because it did not compile before. Now the test is compiling, and now we can run it, and now it will fail again and tell us why it failed. The output of the assert equals table, when there is a mismatch, will list every row in both tables, and at the left column it has an arrow. That arrow points to the left. That means that row is in the expected table. That arrow points to the right, that means that row is in the actual table. If you see an equal sign there, that means that row is in both tables. So in this case we have one row in the expected table and no row in the actual table.
Again, this is actually a little helpful reminder that expected goes on the left and actual goes on the right. And this plays on that idea.
We had that already, so now we need to actually make sure that this view is looking at the orders table. We did not change that it returns hard-coded values, which is fine at this state, because we only have the 2 test cases so far. But at least it returns one row if there is a row in the orders table and no row if there is not. So running those test cases again now will make that test case pass.
So oftentimes it feels silly to be hard coding values in our production code. Who feels silly about that? I feel silly about that sometimes, at least. The reason we do this is if we skip to the end result, if we skip to the code that we want to write that's in our head, because by now a lot of people probably have the idea of the code they want to write in their head. It's already going there. They're just like, why can't I just type it? If you just type in the code, all your test cases are passing, right? If you got the code right, okay? But now there's a whole bunch of tests that don't exist yet that you still have to add. So when you write those tests and you run them, if the code's right, they're all going to pass. If the test case is wrong, it's going to pass. So you have no idea if you wrote the right tests. Nor do you know, or the right code at that point, because if you have passing test cases and the test cases aren't right, then you don't know if you wrote the right code either. So this process, even though it's tiny little steps one after the other, forces you to write the test cases that you actually need to make sure that the code works. And that's the important part, because if we don't do that, we lose our safety net. Furthermore, by doing this in small steps like this, when we're done writing our tests, we didn't write any extra code that we don't need. The idea of writing code that you didn't need is called gold plating, and we consider that waste in our code, okay? If it's something valuable to the customer, we ought to test it. If it's not something valuable to a customer, we shouldn't write it. Carry on.
Carry on. 0-1 sum, the heuristic. Now tells us to write a test with more than one value. I picked 2 rows in this case. And what this is now doing is it's forcing me to actually look at the values that are in the orders table in my code. So the setup of that test is very similar to the ones before. I'm inserting 2 rows. I'm expecting 2 rows to come back. Let me rerun my tests. And now you can see all the 3 indicators in the leftmost column that assert equals table might give you back. So it's saying there's 1 row in there with the equal sign, that row that's in expected and in actual. Then there is 1 row in expected that didn't show up in actual, and another row in actual that did not was not in expected. And to make this now pass, we actually pull the values out of the orders table. Now you see the last column here, the order count, is still hard-coded. So if you want to go on with that, you would have to write a few more tests to make sure that that aggregation now is actually happening correctly. So you would write a test that has 2 rows that belong to the same month and things like that. But for today we're gonna go on to the next example.
So just before we move on though, somewhere back in the beginning of the presentation, Sebastian talked about this 80-20 rule of how much time we spend maintaining existing code and how much time we spend writing new code. If you go through this process, it's going to take you a lot longer to write new code. Guaranteed. If it's not, you're doing something really special and we'd like to know about it. But you're going to spend a lot less time fixing defects because you didn't make as many in the first place. And you're going to spend less time fixing defects because your code is going to be forced into being easier to read. Okay?
So in the overall scheme, while it feels a lot slower to follow this pattern, you're saving a lot of time in the long term. So it is worth following this pattern. There's another way to write test cases. SQL test provides a UI for that too. I can just right-click on the database and say new test. And then type in a test case name here, which you should name better than I did here right now. And what that does is it creates that test in the database and scripts it out as an alter into a new query window where you now can implement your code. And just so that this test doesn't get into the way of our future examples, I'm gonna comment out the failure in there. But now you have that additional test in there. So if you don't like that pattern of having all your tests in one file, if you rather use the GUI to create your objects in the database, you can use SQL test to guide you along there too. It makes that fairly easy.
So somewhere along the way, Dennis did something silly. That would be me. Sebastian normally doesn't do silly things like this. But I forgot to stick the constraints in the database. And, you know, does anybody in here have a database without constraints? Yeah. Oh, I see 1 or 2, a few. And that's kind of interesting. Most of our databases have constraints in them. Inserting data into a table with constraints is a royal, yeah, it's a royal something. So if you apply these constraints here and we rerun our tests,
so one
have
of those constraints that I'm going to add here is a not null constraint on one of the columns in the orders table. the customer's ID. So if I apply those constraints and then rerun my tests, 2 of them are gonna fail. And they're gonna fail because I cannot insert the value null into the column customer ID. So now what happened here, we did a change to the system. That change, a constraint, has nothing to do with the functionality of the view. The view has logic in there. That logic does not depend on constraints existing or not. But it broke our test. And that is a dependency that we do not like, because every time I change something in the database, it might break a lot of tests. So we need to try to break that dependency, to isolate the object under test from the rest of the system. The object under test is a view. The object under test is not the table. So what we can do in this case is replace the table with a test case double. In object-oriented languages, the term mock object or fake object is common. T provides the function or the method fake table. What fake table does under the covers is it removes the original object and creates a new one, a new table that looks exactly like the old one, column schema-wise, but it doesn't have any constraints. All columns in there are nullable, and all foreign key and other constraints are removed. That's okay. This test is testing the view. It's not testing those constraints. The functionality of the view is not affected by the constraints. What this allows us to do is insert data that is important for the test without having to worry about future changes to the system that might prevent my test to execute. So this script now actually contains all the test cases that we had before, but in every test I replace the delete all data from the orders table with a fake table. The fake table, as I said, removes the original table, so another reason to not try this in production. Fake table creates a new table. That new table at that point is empty, so if we need data in there, we can just insert it. And again, we don't have to worry about constraints anymore. So this is what our 3 test cases look like now. And if I compile them and rerun them, they are passing again.
So at this point, are there any questions about what's going on? Any concerns about dumping the constraints off our table when we're testing?
What if you want?
I'm sorry?
Yeah, there's something going through my head there. I'm not quite sure.
Okay. What's going through your head?
How do you get that feedback loop?
I'm sorry?
You've obviously got a system problem now in the real world, with that constraint on there. How are you doing that feedback loop?
Okay. So at some point, you know, your constraint is actually important, right? You spent the time writing the code for it.
Yeah.
And your constraint might just not be, you know, a not null constraint or a foreign key. It could be, you know, a trigger or something like that. You need to test your constraint still, okay? So in that case, what you're really testing is a relationship between that table and that constraint. You might not fake your table in this case, okay? And your test case may say, okay, try to insert a record into this table in a way that should violate the constraint, and then make sure that the constraint gets violated. Alternatively, there's some functionality in T to apply a constraint back. So if you have a table with, like, you know, 50 constraints on it, and you're only trying to test one constraint at a time, you can fake the table and apply the same constraint back. We're not going to go through a demo of that because there's only about 7 minutes left and we understand there's beer outside. So we won't drag you through that, but we do want to leave some time for questions. Does that help answer what the concerns?
So basically if you've got a constraint you want to test, you don't fake,
Yeah.
in fact.
So important there again is
Is that you're testing the constraint specifically rather
yes.
than...
So the constraint is a unit. The view is a different unit.
Yeah.
Test them separate from each other. Right,
So-
procedure?
No, let's talk about the properties of framework and
Oh,
the
yeah.
continuous integration stuff.
So we did see a framework. What we want to talk about now is what makes a good framework. A good framework allows you to group your tests. Related tests should live close by each other. It makes it easier to find tests that belong to one unit or tests that belong to each other. A good framework should promote test case independence. So you want to be able to execute a test without having to worry about anything else around it.
Top of that, you ought to be able to run your test cases in any order you want. And the reason is you don't want to have this tie-in between the first test case and the second test case and the third test case, because you have to add new test cases and change test cases pretty often, just about as often as you change your code. Okay? So if you have this tie-in, this web between all your test cases, and they have to run in a particular order, you're going to really make it hard to maintain. We get away with test case independence by every test case rolls back it. So it starts a transaction at the beginning of each test and rolls it back, which is important so that you're back in the same state. And the next test case doesn't have to worry about the previous one having messed anything up.
There are a few test frameworks out there that actually execute the tests in random order, so that you do not end up writing tests that depend on each other. T-SQL-T does not do that. Well, actually it might. The select statement that selects a test does not have an order by, and SQL Server might return it in a different order. But at least it's not intentionally random. However, because we are rolling everything back at the end of the test, you basically cannot create any side effects in there. The framework should promote self-contained tests. A test in itself should be readable. When you open that test, you should be able to understand what it is doing. That means you should have the setup, the assemble phase in there readable. You should have the other two phases in there readable. If the room within a test case becomes a little tight and you would like to move stuff out, or if you have multiple test cases that do the same setup, you can pull that out into a utility start procedure and call that utility procedure within the test case. Make sure you give that utility procedure a very descriptive name so that you still can understand what's going on in your test. You want to be able to write your test cases in the same language that you're coding in already. The reason for that is that switching the language is a context switch. A context switch for the human brain is a very hard task. It takes a lot of effort. Writing your tests in the same language avoids that switch, so it saves you time and energy throughout the day.
Especially when that other language might be XML, because I know everybody loves typing angle brackets.
Supports testing units. You want to be able to concentrate on that unit under test. You don't want to have to worry about anything else going on in the system. Particularly, you don't want your test to break because something else in the system changed that is unrelated. If that change was related, you might want that test to break if functionality changed. But if something really unrelated changed, like you added a new constraint to the table that the view is looking at, you don't want your test to break. So your framework should support testing, or rather isolating units.
Right. So this is really in contrast to trying to write an integration test that tests a whole bunch of stuff at a time, okay? Integration testing is valuable, and you still ought to do it, but a unit testing framework that's helping you do test-driven development should help you unit test units, because that's what you're working on at the time. When you're ready for an integration test tool, you'll need to identify an appropriate one at that time. But this idea of narrowing down exactly what it is you're trying to test allows you to not have to write a million tests for this giant large system. You can pare down the number of tests that you need pretty quickly. And that makes life easier to maintain.
The last point on the slide is it integrates with the IDE. You want to be able to easily run your tests, quickly be able to see if there are failing tests and things like that. And that's what SQL Test provides in Management Studio. If you want to try this out at home, you can download tsqlt at the tsqlt.org website. That QR code here gets you to my website where you can download the slides. On the tsqlt website you have two download buttons. One gets you to the tsqlt framework itself, the other one gets you to a site on Redgate where you can find SQL Test itself. Yeah, and then go home, try that out yourself. If you have questions, you can find a lot of information on the tsqlt.org website, or you can send us an email. Our emails are here. What we would like you to do